Hello, dear student. I have very important topic for you, the complex number and the important key concept of complex number, the rotation of complex number. You can change the rotate the complex number at an angle and you can find the new complex number, the new coordinates using this strategy of complex number. And it's a simple method, but it is not simple, easy to understand how to rotate this. Suppose we have any complex number in complex plane in the form of coordinates. The coordinate geometry, that is the coordinate of this complex number z1, that is x1, comma y1. That is very simple. Then we can write z1 is x1 I cap and y1 j cap. And we know that the magnitude of this number z1 equal now well x1 square plus y1 square the value of this. Now we can rotate this number at any angle. Suppose we can rotate this angle here, and but we want to change the magnitude also. This magnitude is k magnitude of z1. Suppose, and I will also provide the example of this, and the coordinate of this x2, y2 here. This I don't know, not given. I have to find. I have to find this complex number. This is the complex number is represented as we can say that is Z2. The Z2 is my question. And this angle we have noted this is theta. Okay. So now here we can find this complex number and only the direction of this complex number. The direction of the complex number is only written as in the form of this, that is x1i and y1 j, and here we can put this in the complex form. When we use this in the complex form, that we can use here the real number, here the complex number, that is use this here the vector representation, that is iota. Okay, and here we use this iota, sorry, this is the cap. Okay, and here the value of x1 square plus y1 square is a representation according to complex number style method. Is the direction, and we want to change this as to x2 with angle theta, then we use a new direction number of the rotational number and multiply by this and k mod of z1 here, the mod of z1. When we write z2, it's very simple that k mod of z1 in this way, find we have this length of this and the direction of z1 x1 plus iota y1 and here simply mod of z1 is okay, and the rotational angle in the form of direction. What is the direction of this angle that you have turned this theta? That will be in the form of this cos theta I cap plus, sorry, cos theta plus iota sine theta, and this rotation is along this direction. If we want a rotation along this direction, in this direction, then we use here minus iota. Suppose we want any complex number that is z1 and we want any complex number that is z3, that similarly we use this. This is the cancel out term and we can use this is beta mod z1. It should be now, and the coordinate of this x3 and y3. So we can find it z3 similarly. That is the number of multiply of z1, that is beta, and here the z1 x1 plus iota y1, and we can use the direction number cos minus, and what is the angle you have turned this? Suppose this angle is alpha clockwise. cos minus alpha and the minus I sine alpha. That is, similarly, we can use this as a minus alpha. But we know that the cos minus theta, cos any angle negative inside cos is not comes outside. Here beta x1 plus iota y1 cos alpha plus iota. The sign will change here. This is my sign minus theta will be minus, and the negative with a simple way sine alpha. So this is the representation of complex number Z3. The other important tally out of rotables and the complex number. First we draw a complex number, and after that we can find the rotation of this number. Okay. Now I will use this strategy to find the coordinates of a square if the one vertex of the square is given. Simply, this is the example I will provide to you. So we have given a one vertex of the square, and we know that in the simple case we have this one vertex of the square, that is a comma 0, and we want another vertex of the square, and in this way we can find this. Okay. Suppose we use this strategy to find this. Now we know that the magnitude of this number, this is the z1, and this is equal to a. We can find this with a different coordinate because here the 0 y coordinate, and we know that here this value is given as the angle is 45, and the complex number here this is written as z1 equals to a plus 0 iota. And we know that here this is k times of z1, that is a under root 2, and the angle rotation is 45 from this. Okay, so we can find this here. What will be this? So we can use the similar strategy. This a root 2, here is the number, that is a root 2 is the multiply number beta z1, because that is the magnitude of z1. So we enter z2, and z2 is represented as root 2 times of z1 iota, and what is the change in direction, that will be cos 45 plus iota sine 45. Now we can multiply this as it is. So z2 root 2, and we know that is a cos 45 here. Only direction number having magnitude 1. Be careful about this. A by root 2, and about that this a iota sine 45 and a root 2 iota, and this having 0. Okay. Now we find z2, the complex number of diagonal. We know well this diagonal, and here we find that a plus a iota, and we well know that this is the length equal to a, and this is the length also equal to a for the square, and this length is a root 2, and the coordinate of a comma a of this end of the diagonal. Okay. So to verify the strategy of this to find the rotation of any complex number is confirmed on this case. So this method is used in competitive exams, and one complex number is given and the angle of rotation you have to search or given, then you can find the new complex number using this rotation method. In Demoivre theorem, the rotation method is used as the complex number here, that is the multiplier number. Suppose in this case we can write the k for z2, and we can write z1 e power I theta. Okay? Because you know well that the e power I theta in Riemann theorem is represented as e power I theta, exponential power of I theta is written as cos theta plus iota sin theta. So this is a simple representation to find any complex number when it is rotated at angle theta from z1. And the multiply number in magnitude is the k times, which should be known by you. Yes, we use v. In this case, we use the root 2 times of the diagonal of the side. Okay, then sure be clear the concept. Okay.